Thank you for joining my session. This session is titled Data Dream Workbench with Jupyter hublab and Apache Spark HadoopSparkKafka for geospatial temporal applications. Today, I'm going to talk about how to build an infrastructure that enables multi-user to analyze large amount of data using open source products. Let's get started. At first, let me introduce myself. My name is Shizuka Yasukochi. I'm a data platform engineer in NTT Data. I belong to Around headquarters and my specialty about big data platform. There are my experience. A core development project with Toyota Motors and a data platform for cross-industry. That's all for my introduction. Okay. Here are the contents of this presentation. At first, I would introduce some context regarding this talk, which is the mission of our department, our team, and me. Second, let me talk about focusing on my mission. It to realize a simple use case of data twin computation, which is visualizing and analyzing vehicle or people location information by OSS-based infrastructure. And third, I'd like to show you an example of pitfalls regarding the integration of Jupyter and Apache Hadoop and Spark in our activity. And then quickly summarize this talk at the end of the session. So let's start with the first section of my motivation. At first, about the mission of our department. It's to realize Society DX. What is Society DX? I would share a short movie for you to grab the concept of the Society DX. It takes around 4 minutes. Start.
At NTT Data, we believe that the key to realizing Society DX is digital twin. We'll show you two concepts NTT Data works on, Cyber First and Digital Twin Fusion, that are part of that digital twin technology. First up is Cyber First. The first step for a typical digital twin is to collect physical space data and then use that data to create cyberspace. Conversely, cyber-first digital twins envision ideas using ideal worldviews and prerequisites. They start by building virtually in cyberspace. We then repeat simulations and finally implement that design structure in physical space. From there, real-time feedback results on actions in physical space make continuous improvement possible at all times. The biggest benefit of Cyber First is being able to see the result before actually acting. You can change conditions multiple times in cyberspace to do trial and error, and find more suitable results at a lower cost in a shorter time. For example, when a logistics company is opening a new distribution center, where should it be located? How many trucks will they need? What about shipping costs, operation rates, CO2 emissions? What if they shipped using drones? Cyber-first digital twins allow you to experiment with various conditions, just like building blocks. This screen shows a simulation using a cyber-first digital twin that NTT Data is now testing. You can simulate different delivery routes while changing conditions like locations and vehicle or drone usage, and compare performance from various angles based on the conditions you set. And supporting cyber-first is the concept of digital twin fusion. Digital twin fusion involves taking a created digital twin and combining it with other digital twins for a more advanced simulation. For example, starting with a logistics digital twin and adding in weather and traffic digital twins allows for a more accurate simulation. Another example is if you had a new business idea that taxis carry passengers plus packages of logistics companies, fusing digital twins for taxis, logistics, and the flow of people allows you to simulate the impacts on both taxi and logistics companies. Fusing a digital twin with one purpose with another that has a different purpose broadens the scope of possibilities. We believe that this new development in digital twin technology will be a key that leads to realizing society-wide DX. Society DX.
Thank you for watching. This is our mission. The two essential points of society DX are cyber first and digital twin fusion from the viewpoint of data analytics portion. To realize these points, we need to make sure that we can rapidly develop DX applications and run a cycle of trial and error in a platform, like an experimental environment for digital twin. Okay, next. Our team set our focus how to realize rapid environment of this digital twin. My team's mission is to help data scientists and data engineers to realize valuable digital twin applications. Our main target is testbed. We call the experimental environment testbed for digital twin. This testbed has mainly two kinds of layers, which are MLOps, DevOps layer, and platform layer. Our team has some preset data for our customers to be able to do data analytics quickly. And also, human resource will be given from our team to help our customer to customer try and error their business scenario in our testbed by using some of our technology assets. The testbed implements many useful frames and libraries. You can see many logos. Maybe you may know some of logos. So today I want to look open source because here is Cascap. And my mission. Data scientist and data engineer request me to provide MLOps and DevOps service. So I decided to deploy Jupyter for them. This is my mission. Today, I focus on introducing testbed layer in especially integrate of Jupyter and Apache Hadoop and Spark. Okay. Next is the second section of my challenges and solutions. In this section, first, I will explain the key technology stack in this session. Technology stack of testbed. This is a simplified structure of testbed. At first, I explain three important products: Jupyter, Apache Hadoop, and Apache Spark. Jupyter. The Jupyter is a web-based interactive computing platform. User can write code, run code, and get the result in one place. This picture is Jupyter view. You can see code box, the result, and text. With Jupyter, data scientists can develop application running cycle of try and error. And also, you can get a result as a graph, table, or map like this. Next is Apache Hadoop. The Apache Hadoop software library is a framework that allow for the distributed processing of large data set across clusters of computers using simple programming models. It is designed to scale up from single server to thousands of machines, each offering local computation and storage. In our case, we mainly use HDFS to store large amount of data. As you know, HDFS is distributed file system that provide high throughput access to application data. And third is Apache Spark. Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on a single node machine or clusters. Spark has four kinds of key features. The first is batch streaming data. Unify the processing of your data in batches and real-time streaming using your preferred language, Python or Scala, SQL, Java, or R. The second is SQL analytics. Execute fast distributed ANSI SQL queries for dashboard and ad hoc reporting. Runs faster than most data warehouses. The third is data science at scale. Performance exploratory data analysis on petabyte scale data without having to resort to downsampling. The fourth is machine learning. Train machine learning algorithm on a laptop and use the same code to scale to fault-tolerant clusters of thousands of machines. In our case, we mainly use Spark Core. That's all of the important technology stack. Next, I will talk about my challenges. I need to integrate Jupyter, Apache Hadoop, and Apache Spark to realize very fundamental scenario regarding data science. To do so, I had to overcome three challenges. At first, I need to connect to Spark Hadoop cluster from Jupyter. Because there is a gap between Jupyter and Spark and Hadoop. Spark Hadoop build upon Java technology, but Jupyter build upon Python, and most data scientists likes Python. I need to get them married. And second, I need to build multi-user service on Jupyter. At last, As you know, there are many components. This is nightmare for me because there are compatibility, dependency, and network configurations and more. My boss requests me to automate everything to deploy. Now I'd like to turn to details slide about the first challenge. First challenge. I tried to connect Spark Hadoop cluster from Jupyter. When I look into Jupyter internal, I found that I can select kernel from various options. I put diagram on the page. Could you see? I'd like to explain connection. A user looks at web browser, and the web browser reaches a Jupyter server. And Jupyter server select one of the kernels. In default, Jupyter server connect to Python kernel. And as you see, there is a PySpark kernel. PySpark can speak with Spark and Hadoop. In other words, PySpark is multi-lingual Python. We can write program in Python and PySpark and execute it on Spark Java. You can imagine PySpark is like a translator. And there are two types of PySpark kernel. First is PySpark on local. PySpark on local works with local resource. This is very simple. And another one is PySpark on cluster. It connects to Spark cluster and send a job remote cluster and send job to remote clusters. If you want higher performance, this is for you. Next challenge is multi-user. I use single-user system before the project, and I search solution and ask senior engineer, and I found a solution. That is Jupyter Hub. Jupyter Hub is an application that makes Jupyter to be multi-user system. Now I'd like to illustrate how it works. Jupyter Hub accepts browser's request, and Jupyter Hub detects who connects to servers. If the user already connected Jupyter Hub, reroute his or her Jupyter notebook. And when the user is new, Jupyter Hub asks his or her name and password to log in. And Jupyter Hub also runs Jupyter Notebook for him or her. Then we root new notebook. And so he and she happily use their own notebook on same server using Jupyter Hub. Third challenge is solve compatibility and dependency problem and automation. This is the hardest task with a solution. So I decided to adapt the solution that open software community has already provided. And yes, I find distribution. Distribution is a mainstream solution. Do you know Red Hat CentOS or Ubuntu? Distribution solves us about version compatibility. Which version of open source is best, and they also provide an installer. same fear for big data software. That name is a Big Top. Big Top are Apache projects that provide packaged and installable big data software environment. OSS community has already tested the combination of software and give us recommended settings. Here is a list of products in BigTop distribution. Now I explained our solution, but the road was not straightforward. Actually, I walked like snake. Sometimes I fell into pitfalls. Next, I want to explain how to rise from pitfalls. A key component of Jupyter Hub. A Jupyter Hub has three components. First one is HTTP proxy. I already explained previous page. Proxy accept a web browser connection. Second is authenticator. As I explained previous page, when new user log into Jupyter Hub, authenticator check username and password by authenticator check by Linux local user or LDAP. And third is spawner. This is problem. As I tell previous page, Jupyter Hub launched Jupyter notebooks actually run new process. So spawner born new process. That is why the spawner is given such a name. Spawner list. There are so many spawners. Reference is backend. For example, first one, a local process spawner runs a notebook server as local process. And second one, Docker spanner spawned a notebook server on Docker containers. And I look into spawners, and there are three candidates for our team: Docker spanner, Kube spanner, systemd spanner. At first, I want to use Docker spanner or Kube spanner because I want to get containers isolation and security benefits. But Docker spanner is not easy for me, and Kube spanner is even tougher for me. So if I use them, I have to learn an extra layer of container. Finally, I selected systemd spanner. Systemd spanner is fit for me as an ordinary Linux user. And I found that I can get isolation and security benefit from systemd spanner, similar to containers. When I selected systemd spanner, I have believed I can get the benefit smoothly. But I fell to pitfalls. First pitfall is compatibility issue. I installed Jupyter Hub and systemd spanner on CentOS 7 server. Systemd spanner version is 0.15. It's the latest version then. But unfortunately, Jupyter Hub doesn't work. I check the error text and search a solution and find that systemd spanner version 0.15 doesn't work on CentOS 7 and version 0.14 can run on CentOS 7. So I tried it I tried version 0.14 and system spawner started to run. It is good. It is good that it worked, but unluckily, there is a problem with version 0.14. Version 0.14 has a vulnerability. Yeah, the vulnerability is fixed in version 15. If I want to continue to use system spawner, I need to change OS or give up system spawner and select another spawner. In order to change OS, we need another OS to support. As you know, because CentOS 8 become ended. So it is not simple to switch events because I need to ask our support team and our support team. It is not easy. Second pitfall is about security features. A table shows us security feature on each system version. If we want to spawn a completely independent Jupyter server for each user, you require at least version 228 or higher. Yes, and CentOS CentOS 7 latest system version is 219. So I found that I need to change OS. Same here, yeah. Same pitfall 1, yes. As I talked in the first pitfall, it is not simple to switch other OS from CentOS. That is the end of the main body. Last is our result and future work. Here is the last page. Allow me to wrap up the session. First, I connected Apache Spark and Hadoop with JupyterLab using PySpark. And second, I also have deployed Jupyter Hub to realize multi-user analysis. And third, I used Bigtop solution distribution to deploy quick and automatically. And I attacked I tackled several issues on Jupyter Hub, and now it works well. But I still have a challenge. I want to change first. Still have challenge. I want to change Sparner for better system for futures. It is because we need to realize multi-tenancy service. At last, it's just my comment. I want to visit Taipei and talk with you, but now COVID-19 limit my trip. This is a photo of Taipei 101. The building, there are many companies' offices are located as tenancies. So it is an image of multiple tenancies. I will visit Taipei and meet you when I finally get the perfect system and also get many bonus. Thank you for listening.